Okay, everyone, welcome into LPKF Studios. It is 11 o'clock, and we're going to go ahead and get going. So welcome to today's webinar, which is UV applications from prototyping to production. Today we're going to be talking a little bit about UV lasers and the types of circuit board applications that UV lasers really benefit. Who's presenting today? Well, my name's Shane. I'm a creative marketing specialist here at LPKF. Basically, I make webinars, I write papers, and I make videos about our technology here. Joining me today is Rory Grondin. He is our senior sales associate, and he's our go-to for when it comes to UV lasers for prototyping circuit board applications. He's a graduate of Oregon State University. Thanks for joining us today, Rory.
Absolutely. Thank you, Shane.
Yeah, and also joining us today is Mirella Orlovsky. Mirella is a sales engineer. She earned her electrical engineering degree from nearby Portland State. I'm a Portland State alum myself. Go Vikings. Mirella, thanks for joining us today.
Thank you, Shane.
All right, let's get going. If you have any questions throughout today's webinar, go ahead and submit them via your go-to webinar questions panel as seen on your screen. We're going to go ahead and answer questions at the end of today's presentation. I also wanted to add that if you want to submit your question via Twitter, you can. You can do this by tweeting your question to our Twitter account at LPKF_USA. 1,000 bonus points to anyone who submits their question via Twitter. But let's go ahead and get started because that seems like a good thing to do. So we're going to talk a little bit about UV lasers and why they're so perfect for circuit board prototyping. Well, as you can see on the screen, UV lasers have a very short wavelength. It's actually shorter than the wavelength for visible light. Now, this short wavelength allows for very precise focusing and the generation of fine features. It comes in really handy when you're dealing with circuit board features that are very small. In addition, the high photon energy behind UV light really makes UV lasers ideal for material processing. If you wanted to compare a UV laser with other lasers, you could take a look at the chart that's now on your screen. This compares the absorption rate of various materials for a variety of lasers. So I'm going to highlight the UV laser here. It's a 350 nanometer laser. And you can see the absorption rates for different materials. You can see very high absorption on resin, very good absorption on copper, and even some absorption of glass, which is pretty low for a lot of different lasers. Backing up just a step to highlight the CO2 lasers on the left, you can see on the right, the CO2 lasers on the right, you can see very good absorption for resin, very good absorption for glass, but there's very little absorption for copper. Finally, the other laser I wanted to point out is the Excimer Laser on the left. Now, Excimer Laser measures very well in absorption rate for the three different materials we're looking at, but most people are priced out on Excimer lasers, and so that kind of makes UV a very good option for everything in between. So some of the benefits of UV lasers, we're going to talk in general right now, so benefits of UV lasers. First of all, there's no mechanical stress. If you're working with a circuit board application, with a traditional mechanical method of maybe surface etching or drilling or depaneling, you always incur some sort of mechanical stress. So by replacing a physical tool with a virtual one, any mechanical stress effects are completely eliminated. Next, UV lasers generate a small amount of heat, so there's very limited thermal stress. Finally, because as we talked about with the short wavelength, you can create very fine features and very precise focusing, which allows for very high accuracy when working with circuit board applications. Another great benefit of UV lasers that applies to all applications is minimized debris. So I know certain methods for circuit board processing can cause debris that could damage sensors or components, and one great thing about blading surface material is there's really no debris that can damage anything. And then finally, we have material diversity, which we're going to talk a little bit about on this slide, and we'll get to more in the presentation. But UV lasers can really process a variety of materials, everything from basic FR4 to RF and microwave Teflon composites. Flex materials is a huge area of application for UV lasers, as well as fired and unfired ceramics. And we're going to see even more materials that UV lasers can process. I need a little moment to catch my breath, so I wanted to bring in Rory and Marilla to talk about the types of different UV systems that are available. Rory, talk to me about, just really quick, tell me about UV systems for prototyping circuit board applications.
Yeah, well, here on the screen you can see that the prototyping lasers and lasers in general have actually come down in size and are now turnkey systems available on the industry market, which allow for compact machines to be created and implemented into a lab environment. So very small and very user efficient for a lab setting.
Gotcha.
Yeah, the laser you can see on the right is really the more traditional laser used in production applications. But now the great thing is that even in productions, even in the production applications, there are lasers available on the market that are similar to the laser you see on the left in size. So you can also put them, you can put multiple lasers in a really small like production area. So that has been really popular in recent years.
And then Marilla, for the production UV systems, those can be either inline or standalone, correct?
Absolutely. In fact, the system you see on the right is typically an inline system.
Gotcha. Thanks, Marilla. So now I wanted to cover the applications we're going to go over today. First of all is surface etching, which is really going to focus on circuit creation. Then we're going to talk about depaneling, which is a huge issue, or huge area of application for UV lasers. Then we're going to get into drilling, and finally we're going to follow that up with depth engraving or pocketed creation, as you may know it as. And then we're actually going to have a little subset of depth engraving, skiving. Now skiving, when we refer to it, we're referring to removing organic material off of metals. It's basically a type of depth engraving or pocket creation. You may know it by another name, but we're going to cover that right at the end. As we walk through the applications in today's presentation, we're going to have a scale. It's basically our production capability scale. And we're going to be ranking each application that we look at. Basically, what's the quantity you could produce with a UV laser? And we understand that small scale for one company could be different than small scale for another. So we're just trying to give a rough estimate of what you could actually produce feasibly with a UV laser system. But we're going to go ahead and get started with surface etching. There are a few main benefits of surface etching when it comes to UV lasers. First of all is smaller traces and spacing. Basically, you'll be working with a 15 to 20 micron beam, and this is going to help you create fine features. Next are straight sidewalls. This is very good for RF applications. Because of the vertical beam of the laser, you will have straight sidewalls. And finally, there's minimal effect on the substrate. This is partially due to the low stress factors, but Rory's going to get into that a little bit more. So Rory, why don't you talk about our first application, which is metallization removal on FR4.
Yeah, unique with the UV lasers and the versatility that's offered when the absorption rate can be controlled for metallization removal is that we can actually create very small features with FR4 material, as you see here in this picture. You actually can either do ablation, where the beam paths are placed right next to each other, or you can do a hatch and delamination with patented technology, which actually removes metal faster. So this clean removal process, because the minimal heat that's created with UV lasers is ideal, and then it's referred to as cold ablation in the industry for research and development, and something that's very common for prototyping circuit boards, RF, digital, analog, millimeter wave, and so on.
Mm-hmm.
And so here you can see in the scale on the top right corner that it's very common for research and development. But when you get into production, chemical etching may be the best method for this type of material on a massive scale, and something that performs very similar, if not on the perfect scale, with chemical etched versus the laser, because you're creating the board as it is intended and how it's simulated, and you get very good results.
Gotcha. Moving into another type of circuit creation and surface etching on UV lasers is when you're working with ceramic materials. Talk about that, Rory.
Yeah, this is exciting for the UV laser because fired ceramics or alumina or AO203 come with a wide range of metallization. You can have tungsten, nickel, copper, nickel, gold, and the laser is able to remove all those metallizations with very fine precision, talking about the Gaussian beam, getting it focused, very small, 15 to 20 micron, and then the straight sidewalls with the theta lens and the galvo scanner giving you vertical impact. So here you can see this board is about 1/2 inch by 3/4 inch with 2 mil traces and 1 mil spacing, or 50 micron and 25 micron, and it can take about 45 seconds to create this. Mm-hmm. So what we're seeing is that this is very common for research and development, something that application engineers love. But we're also seeing it start to trickle into small scale and even medium scale production, because the lasers are very versatile and very fast, and quantities may be in the range of hundreds to maybe a few thousand. In fact, I have a customer that's working with filters, and they're actually creating 500 custom filter designs per week using the UV laser. And then if the design was the same, you could actually just panelize it and run upwards of 5,000 filters per week. So very exciting and very fast for the fired ceramic industry.
Gotcha, and it's cool to see how versatile you can be with the quantities on that. I wanted to get in another really exciting application for UV lasers, which is actually working on touchscreen material. So I wanted to bring in Mirella here to talk a little bit about working with these sort of glass materials.
Yeah, so working with glass materials are another really important section of working with UV lasers. In this particular case, what you're doing is you're removing coating off of glass. And this particular picture shows the TCO coating, which is the transparent conductive oxide coating. And the great benefit is that you're able to remove this coating extremely quickly and cleanly. So there's no damage to the glass. You're able to create very fine lines. Here you have traces as small as 1 mil. And because you're able to do it so quickly, it is great for production applications. So in fact, we have a customer in Europe that's using a UV laser for this particular application. They're removing TCO off of glass. So it's really a great application for a UV system as well.
Gotcha, and it's nice to see you can, again, get into the higher quantities.
Oh, absolutely.
Yeah. Wanted to have Roy jump back in for this really sort of exciting new application that UV can handle. Talk about this one.
Yeah, here we have polyimide, which Acaflex material is a specific polyimide from a German company. And polyimides with lasers pose a problem, because with the lasers, they're designed to cut through polyimide and extremely fast. So what this speaks of is the versatility and control that we have of the laser itself, the power, the pulse frequency, and travel speed can dial in settings. And this is an exciting application that is gaining ground as far as its capabilities. So we removed quarter-ounce metallization and created traces and spacing as small as 4 mil with this 2 mil thick Acaflex, and that actually has quarter-ounce copper. So very exciting, and an application that is perhaps on its way to start trickling into small-scale or perhaps even large-scale production.
Very exciting. And Roy, you actually mentioned that UV lasers are kind of designed to almost cut through polyimide, and that actually leads us into our next section, which is depaneling. So I wanted to talk about this because this is a huge area of application for UV lasers. Some of the benefits of depaneling circuit boards with a UV laser includes very limited stress. Again, we mentioned no mechanical stress and very low thermal stress due to a small heat-affected zone. One of the benefits for depaneling of that limited stress is you can place components such as ceramic capacitors really close to the edge of the board. And another benefit of that is increasing your yield. So basically, you will have less boards end up in the depaneling line waste bin due to the low stress. And finally, because of the small beam, you can place more boards per panel, getting a more efficient panel rate. But I wanted to bring in Mirella because she's kind of our specialist when it comes to UV depaneling. So walk us through this application and the benefits of UV.
Yeah, so UV depaneling is used more and more, or UV lasers are used more and more for depaneling applications on the market today. UV lasers are super popular for this particular application. The reason we chose this part to show you is because it kind of covers a lot of bases. Here what you're doing, or what you can see, is we're cutting flex, rigid, and copper with the same laser. And not only are we cutting it with the same laser, we're cutting it all in the same job. So what you are able to do is you can set parameters for different materials in the same, you can set parameters for the different material in the same job, and then you do not cut, let's say, the polyimide with the same power you would cut copper with, and you do not damage it in any way. So you can see there's no thermal effect on the material at all on the polyimide side, but then on the copper side, you still have enough power to cut through it. So this is really a great application for UV lasers, and it's definitely a large-scale application.
Gotcha. Then as we mentioned earlier, one thing that makes it so remarkable is that can actually cut through the copper, right?
Oh, absolutely. So there are certain lasers on the market that are popular for the paneling application, like a CO2, but the downside of that laser is that it cannot cut through copper. So it wouldn't be able to complete all of these or do all these applications at all.
Gotcha. And then production is going to be really high on this one.
Oh, absolutely. Very high.
So moving into our next application for depaneling, you can see this FR4 application, and you can see a little bit of the components. So talk about this one, Marilla.
FR4 is a very standard material that's used in the PC industry today. It's a material we encounter extremely often. This is a great example of the application that kind of covers all of our benefits. So you see here we're cutting parts that are very small with components close to the edge. We're able to dial in our settings so we do not damage our components in any way thermally or with any sort of stress, because again, there's no stress when paneling with the UV laser. And also you're able to increase your yield by not only damaging components, but by placing your parts very close together. So you can have more parts per panel in this case. So this, when it comes to the production capability, it can be used in medium and large scale production. But what I also want to point out that often UV laser, when you think of UV lasers, you think of cutting pretty thin materials. So, in this case, we're cutting a 600 micron FR4 material, and we're cutting it very efficiently and very quickly. But now there are also lasers available in the market that have quite a bit more power and that are more suitable for cutting FR4 that's maybe 1.5 or 1.6 millimeters thick. So it's 62 mils thick, which is really kind of opens up the door to some new markets and some new applications. And the great news is that you keep that same quality of the cut, even though you're using more power. Your sidewalls are going to still be very straight, and you may have a little bit more charring because you're using more power, but not that much more charring to affect the part in any way.
Gotcha. So it's nice to see, depending on the thickness of the board and the power of the laser, you can go different scale quantities.
Yes, and you have different options with laser sources as well.
Gotcha. Our final application for the depaneling section, I know, is actually made on one of the UV lasers we have right here in the office by Rory himself. So Rory, talk about what we're looking at here.
Yeah, here you can see other materials. Just like with the FR4, settings can be dialed in to cut with a number of repetitions through different types of substrate. And so we see a lot of PTFE RT Duroid substrates, which would be basically Teflon based with random glass or ceramic fill. And that's something that cuts very easily with the UV laser with clean edges and no heat effect. And on the right you can see the fired ceramics, which is also depaneled with the UV laser. And that's the same sample we saw earlier, and it only takes about a couple minutes to actually depanel that 20-30 mil thick ceramic sample. So very quick, something that we see a lot in R&D and small and medium scale production because it's quick and clean, and with the reduced heat and reduced residue, you have much less post-process cleaning, if any is even necessary.
Yeah, and I know with ceramics that's a huge area of depaneling for UV because wouldn't like mechanical methods, say such as routing or pizza cutting, that would kind of like crack the ceramics, right?
Exactly. If you're using mechanical methods and carbide tools or pizza cutters, fired ceramics aren't going to agree with that very well.
Yeah.
So you either crack the material or dull the tool, but the laser can get through that material just by controlling repetitions very quickly and give you that versatility that covers such a wide range of projects.
And what's really cool about this application is you can see the holes in the material where it also drilled it, and that actually leads quite nicely into our next section, which is drilling. And you can actually drill through materials with a UV laser. And what's pretty amazing about that is because of, again, the reduced heat effect zone, you're able to have no delamination. So this is especially important when you're working with multi-layer materials. You're not going to see any delamination in between the materials. And finally, because of the small beam size, you can have holes that are very, very small. So I wanted to have Marilla jump back in here and walk us through what we're looking at here.
Yeah, so what we see here is we're drilling through a multi-layer flex circuit. So the circuit consists of polyimide, copper, and then adhesive that bonds them. So with a UV laser, you're able to drill cleanly through all of the layers of the material with with straight sidewalls, and you're able to control your power so that you may have to increase it in certain areas if you're going through copper, and then you can decrease it again if you're going through polyimide. That's a great benefit of a UV laser. So also, there's really no bit wonder. So because you're going straight from your data to cutting or drilling, and you're eliminating the middleman. So there's way less room for error. This is a very typical application that's used in production. So you can use it on, anywhere from very large scale production or in prototyping applications to prove a concept.
Gotcha. Looking at this next slide right here, we see some more of the ceramic substrates. I know you've been talking a lot about that, Rory, so I'll just bring you back in for this one.
Yeah, this is something that's becoming even more and more common for the UV laser systems. There's other methods for drilling ceramics, in fact, more standard methods, but the lasers that are traditionally used for that can actually generate a lot of heat and a lot of slag residue and carbonization on the material or perhaps on the gold surface, which is highly undesirable when you're doing RF applications or filters and couplers. So with the UV laser, you can actually cut and drill, here in this case, drill the fired ceramics with very small holes and have very clean edges and minimize the risk of microfractures. So on the left, you have fired ceramics and a larger 1 millimeter hole in 0.6 millimeter Al2O3 or alumina. Now that hole actually is cut extremely well, even on the front and back side, and has very consistent hole diameter on the entry side and on the exit side. It's not as fast as the next application where you have unfired ceramic, and the unfired just absorbs the UV wavelength much faster, and you get faster ablation of the material. And so you can actually go smaller holes with the unfired material because your energy is being absorbed at a different rate. And so it's going to be faster for unfired ceramics for drilling and a little bit slower for fired ceramics, but still very quick and acceptable in the research and development side. And then if it's an application where you need those clean results, then you see that even with fired ceramics, small scale and medium scale production is very possible.
Gotcha. Thanks, Roy. Another drilling application I wanted to bring up, which is a special kind of drilling, is blind microvias. Marilla, why don't you talk a little bit about these?
So what you see here is instead of drilling through holes, so all the way through the material, you actually stop at a specific layer in your circuit. And really here what you do is you stop at a layer of copper. So often if you ever worked with blind microvias, you can go through copper and substrate and then stop at the next layer of copper, or you just go through substrate and stop in the next layer of copper. The great thing about UV lasers is that, as we've been saying this whole time, you're able to control the power of your laser so well that it doesn't matter how deep or how much of the substrate you have to drill through. You're always able to stop and set your parameters such that sometimes you may have to stop after 100 microns. In a different application you may have to stop after 250 microns, and you're always able to do so because you're able to control your laser power so well. This application can definitely be used in R&D and small and medium and large scale production. And because you're working with a 15 to 20 micron beam, you have a lot of options in terms of your hole diameter as well.
Gotcha. And in a way, I could really think of drilling as a form of depth engraving, right?
Oh, especially in this case, because that's kind of exactly what it is. You're not drilling all the way through, but you're stopping at a specific layer of a material.
Gotcha. And that was a perfect segue into our next section, which is depth engraving, or you might know it as pocket creation. So basically, the creation of steps within a circuit board application. Great benefit. We've been talking about that small, accurate beam with the vertical cut. So you're going to have very straight sidewalls, again, great for RF applications. Because of the low stress factors, you're going to have burr-free openings when you create those pockets. And finally, because of the precise focusing and the way the galvo scanner is set up, you can really create any shape you need. So I wanted to bring up this application right here. Rory, walk us through the different steps we see in this application.
Yeah, this is a material, and then talking about organics and polyethylene in this case, you have a substrate that, with control of the UV laser and repetitions and power and pulse frequency, which are easily saved and then and put into tool libraries for use, you can control the number of repetitions and actually remove very precise amounts of material. Here you can see that the first pocket was 2 mils deep into the substrate, and then a second pocket 8 mils deeper than that, and a third 10 mils deeper than that. And so your total thickness or total depth of cut could be 20 mils in this particular substrate. And we've seen that with different materials, your control can be extremely advanced. When removing an epoxy substrate over a circuitry that maybe has wire bonding, we've actually been able to remove high sol epoxy in as little as 5 to 10 passes. Or thermoset resin over the top of a metal, and we remove that in maybe 2 passes, but it's 20 mils thick, so maybe 10 mils per pass or 1 mil. And then we've even dialed it in where metallization removal on a substrate can be done where approximately 1 micron of copper is removed from an actual circuit board substrate. So incredibly accurate.
Yeah, and to tie into that, I just want to remind everybody, in this case, the pocket creation was only done in one substrate, but you're able to do pocket creation in a multi-layer board as well. So you can remove, substrate and then metal and stop at the next layer of substrate, or remove more substrate, stop at the next layer of metal, and so on. And in fact, very recently, I had the customer that did that very thing. That was one of the requirements.
Gotcha. So on this side, as Mirella mentioned, you can cut through a variety of materials. You can see here the different metals, and then the organic substrates.
Exactly. This we can see metallization being depth engraved, or having the pockets created in copper, aluminum, nickel, different types of metals that still absorb the UV wavelength. And then with circuit board applications, you can do exactly what Mirella mentioned with her contact that does the multilayer. Very popular for research and development, and then for small scale production, it's becoming something that's even more popular for microfluidic applications and microrobotics, where maybe the high scale, the laser that you mentioned before that the price points out, this lower cost UV laser sources are allowing these types of applications to be done where it's an organic substrate, but the repetitions and control you can actually go to set depths in those materials.
And Rory, I just wanted to ask you, actually, because you talked about multiple passes on the materials, it's still a very quick process, right?
Oh yeah, the passes happen in fractions of a second, and the laser and the galvo and the scanner all implement each other and complement each other so that a repetition may be a portion of a second.
Gotcha.
So yeah, very, very quick.
Thanks for explaining that. And then actually, so our last section of application for UV lasers is Skyping. And again, I know there's some different terms in the industry for this. We're referring to the removal of organic materials off of metals. And some of the benefits UV has for this one, again, small beam diameter and very accurate beam means that you're going to have very fine openings when you need to create a pocket and open up some material underneath another. Finally, because of the low stress factors, you're not going to damage that lower substrate. We've seen this with the depth creation, with the surface removal on glass with the transparent conductive oxide. You're not going to damage the lower substrate. And finally, again, in the beginning we talked about minimized debris, so you're going to be residue-free. I wanted to bring in Mirella to walk us through a Skyping application. So talk about this.
So this is one of the Skyping applications you could see on the market today pretty often. So in this case, you're removing polyimide to expose a copper pad below. The great part is that you have such control of the laser that you're able to control the diameter of your opening very well. So in this case, on your left, we have an 8 mil diameter opening that's a little bit larger than the pad itself. And the reason for that is because the customer requested it that way. But you're able to create an opening that's the same size as the pad or a little bit smaller, and you're able to do so very precisely with no thermal effect to the polyimide in this case, which is very important because you don't want any charring on those edges. And also, as Shane just mentioned, the great benefit of Skyping with the UV laser, residue-free. So you do not damage the surface below, and you're able to keep that, in this case, the copper practically intact. This laser is extremely fast when removing thin material like polyimide, so this is definitely a large-scale application.
Gotcha. And then just to quickly add another Skyping application, tell us what we see here.
Yeah, this is just to kind of show you a variety of Skyping, and in this case what we're doing is actually removing solder mask. So again, because this image is nice and zoomed in, you're able to see that the solder mask, which is very different from polyimide, is also removed very cleanly. You can take a look at the edges, and the surface below doesn't have any residue on it. So it just kind of reiterates that UV lasers are great for this. And in fact, I have a customer that has a large production system just for this type of application.
Gotcha. And then again, it's very high scale production.
Absolutely, very high.
Gotcha. Well, that's actually the end of our applications section. So we're going to have a Q&A in just a moment, but I thought I'd wrap things up first. So in the beginning, we talked a little bit about why UV light, and then as a result, UV lasers are ideal for material processing. Again, that short wavelength and the high photon energy. Again, because of the short wavelength and the small heat affected zone, you have little to no stress. You'll see no effects of mechanical stress as found with mechanical traditional methods, and you have very low thermal stress. Again, because of the short wavelength and the way you can focus a UV laser, you are going to see very fine features and very high accuracy. Finally, we talked about material diversity. I mean, we've seen a lot of materials today, everything from FR4 to polyimide to fired and unfired ceramics, and as well as even like something exciting like transparent conductive oxide on glass for touchscreens. And then the applications. You basically can do anything you need to do to a circuit board, you can do with UV lasers. You can create the circuits, you can drill it, you can depanel it, and you can open up pockets and Skype as well. So it's very versatile. I wanted to point out the picture on the right. I know I mentioned that UV is shorter than visible light. That's actually just an artist's interpretation of what a UV laser beam would look like. I wanted to thank everyone for attending today because we've reached the end of our presentation. We are pretty excited about your questions, so feel free to start getting those in. If you have any questions about UV going forward, I wanted to throw out some emails right now. For prototyping questions, Rory's kind of our specialist on that, so it's rgrondin@lpkfusa.com. And then for more large-scale and medium-scale production applications, you'll want to speak with Morella. So that's M. Orlowski, that's MORLOWSKI at lpkfusa.com. I want to say a little bit just about LPKF as a company so you know where we're coming from. We are a systems supplier. So basically, we manufacture systems for circuit board processing. In this case, as you can tell, we're really big UV evangelists, and so we produce both prototyping and production systems for UV processing. We have a variety of segments within our company as well. We do everything from prototyping of circuit boards to PCB depaneling. We have specific systems just for that. We also have laser direct structuring for MIDs, laser plastic welding, SMT stencil cutting, and the scribing of solar cells. But we're going to go into questions now. So if you have any questions about anything you saw, or any questions about maybe an application you have, or anything about UV in general, go ahead. While people are submitting their questions, I wanted to launch a poll. Basically, what are your thoughts on UV circuit board processing? Maybe you have a potential prototyping application. Maybe you have a potential production application. Maybe you just like some more general information, or maybe you're good for now. This presentation kind of covered everything you needed to know. It's just some feedback for us so we know better how to follow up with you in case you do have any further questions. Again, thanks everyone for joining us, and start getting your questions in. I'm going to put the I'm going to keep the poll open for another minute, and then we're going to go ahead and get into questions.
And I also wanted to mention another thing is if you didn't see the application you have on the list here, don't be afraid to ask about it, because what we listed are probably the most typical UV applications or applications we see in the lab here. But trust me, between Rory and I, we have done a huge number of different type of applications that you wouldn't even think could be done with a laser. So please feel free and ask.
Gotcha. And then, like I said, we'll get we're going to start gathering up the questions that have been submitted so far, and we'll get into them in just a minute. Thanks. Okay, so we have a bunch of questions, so we're going to walk through them one at a time. So stick around, and we're going, like I said, we'll go through one at a time. We have quite a few, so if you don't hear yours right away, just we'll get to it as soon as we can. So our first question comes from Doug Shade, and I wanted to say that Doug had to say, he asked us if we could say a word or two about laser direct imaging, basically a direct write to photoresist treated copper, basically a PCB laminate sheet.
Yeah, we actually have resist applications from time to time, and in fact, I have a customer right now that's doing a very similar thing. So you can ablate resist very cleanly and quickly with a UV laser. It all depends, of course, on the type of your resist, how thick it is. So there's certain parameters, or there's certain things about your project that you would have to tell us, and one of the main ones is the thickness of your photoresist in this case. So, but it's one of those questions. If you need additional information, please contact me, and we can talk about your specific project. But yes, it is possible.
Gotcha. Our next question comes from Michael, who wants to know, can you measure the depth? And I'm assuming he's referring to the depth of cuts.
Yeah, the depth of cut on the machine itself, the UV laser, there's fiducial cameras for alignment, and there's very precise XY tables on many of the machines that are offered through LPKF or are on the industry. Mm-hmm. For depth of cut, there's equipment that can measure it. And when we do research and development applications, that's one of the key things, especially for microrobotic applications and microfluidics, where they want to know how deep they went. And basically, it's a function of dialing in the settings, measuring the depth, and then saying, all right, at this frequency and this travel speed, we went to a set depth of 5 microns or 25 microns or 500 microns. And then you can control how deep you go on your design and assign that to areas of your layout. So measurement is done in correlation with the laser, but with secondary equipment, and then you can totally correspond that with the machine itself and changing the settings to dial in, and then save that tool for set depths in certain types of materials, and then it's referenceable.
Gotcha. Thanks, Roy. I have a couple questions from Thomas. He wants to know, must the material being used in the UV laser, must it lay flat? Is there a means of holding the material so as to machine from different sides? And I know we have some options for this, so why don't you guys, maybe Marilla or Roy, take this one?
So it really depends on the application. For LPKF, we have a couple of different options for you at least. If you work with a lot of very thin materials like polyimide or PET sheets or something like that, we have systems that come with a vacuum table. So the vacuum table will hold the material down while cutting, and it will hold it perfectly flat, and you don't need any anything additional to keep the material down. If you have a board that's populated, especially if it's populated on both sides, then you would go with probably one of our other systems that requires or comes with a fixture. So you would get a fixture that fits your specific panel perfectly, and it can cut from either the top or the bottom, and that would hold your panel in place.
And on the prototyping systems, the research and development machines, the vacuum table is included in the standard features.
Yes.
So when you get to the production, that's where Marilla has many options.
Yeah.
Cool. And then Thomas had a follow-up question just really quickly. How could we metallize the via hole? Well, what are options for that?
Yeah, there's several options. LPKF's been in the circuit board industry for over 37 years now, and we have a silver plating option, which is a paste that can coat sidewalls, which is great for prototyping. We also have copper plating machines that actually grow copper and bond it with the material using a activation ink and then a copper plating bath. So those are two options. But when you get to fired ceramics and alumina, there's a third option where you can actually have sputter coating performed after you've done the laser drilling. And then you can come back and then have the laser do the surface etching and create the design, drill it, cut it out, all on that same system. So there's secondary plating options that are on the market.
Gotcha. Okay, thanks, Roy. So our next question comes from Kelly, and he wanted to know, I brought up slide 21, because he said on slide 21 there are 2 local fiducials next to each circular PCB, or are those holes something else? So Marilla, do you know what those, what he's talking about are?
Yes, those actually are fiducials, and they are 2 local fiducials. So let me mention fiducials right now. This is kind of a perfect opportunity. So with at least our UV lasers, especially the one for production, you have several options in terms of fiducials. You can read global fiducials. So if you have a board that has, you have a panel that has maybe like 6 parts on it, they're larger, and you're okay with reading 4 fiducials that are on the panel itself and then cutting everything else out, great. You're able to do that. If you're working with a board such as the one that's shown here, you really need a little bit more accuracy. So what you're going to do is you're going to read fiducials, like you mentioned here, local fiducials for each separate part. So you have your options on, do you want to read local or use local or global fiducials depending on your project.
And then the software actually does the alignment within its internal algorithms and adjusts the X, Y so that you go straight from laser to the material.
Yes.
Gotcha.
Yeah. really the first thing that the laser does when you press start is it looks for the fiducials, reads the fiducials, and then it starts processing your board, whatever you need to do.
Thanks, guys. I wanted to bring our next question up from Jody, who has a question that I know we can is pretty cool. So, can the laser double as an engraver for labeling?
Yeah, with a wide variety of materials. If you just need to mark and engrave, the systems allow you to control the settings down and just do a quick mark on the material, the component, the IC, the BGA. If you wanted to put your logo on it, it's all just a function of importing your design data and text, and it can easily structure that text and etch it on different material types. And then I think Marilla has some additional details with the production capabilities.
Yeah, with the production, there are certain production machines that have a software option where you can do some sequential barcoding as well. So, I mean, with these type of machines, sometimes we have people call and ask, hey, you know, can we just use this machine for engraving? You know, really, because this laser is so versatile and capable of so many different applications, I wouldn't say that engraving is the #1 use for it. Not because it cannot do it very effectively. It's because, you know, it's really designed for various PCB processing application. I think really the engraving is kind of a great side capability of it.
Bonus.
Yes, kind of an added bonus.
Gotcha, thanks. John wants to know, I actually I answered this in a way when I mentioned that we are a systems supplier, but he wanted to know if we have a system that performs the functions described in this presentation, and he kind of wants to know maybe some rough budgetary costs on that one.
Yeah, we can provide pricing information as needed. We have several different machines, and for the prototyping side, there's the ProtoLaser U3 available from LPKF, and this system is a high-power 6-watt UV laser system that is at the 355 nanometer and has a 15-micron wide beam width, and it's actually the system you see on the left in the picture Shane pulled up, and that system's about $220,000, but it's turnkey. It means it includes the software that you need for operations, the dust extraction that you need for pulling away any particles and debris that the laser is creating, which the dust extraction is designed for Nd:YAG and CO2 laser cutting, and then it also includes installation and training. And so that's a rough estimate, and actually because LPKF generates our own laser sources and implements that into our machines and has engineered these to be very compact and repeatable from production to prototyping machines, the cost is actually lower than what you would see for the industry for a 6-watt UV laser system with this much versatility and this advanced software that allows you those options to change settings.
Perfect. All right. Our next question comes from Caleb, and I think it'd be near impossible to answer Caleb's question right now, but he wants to know if there's a list of all the applications performed on UV lasers thus far.
So Caleb, if you want to email Rory or I, you can maybe mention your specific application. Because we have so many different applications that we get through, in a week, let alone a year, it would be nearly impossible to list them all. But I mean, we've done everything from, one of the applications that I had that can be considered odd in the PCB industry is ablating ink. I mean, we've ablated ink from acrylic. That's also used for like displays and cars and so on, which is not a PCB application at all, but it's beautiful with a UV laser. And Rory has, I'm sure, quite a few as well.
Yeah, we do keep track of the applications that we see come across and actually make sure that we have settings that are dialed in so we know if it comes up again that we can pull it up within the software and have a setting that's for that type of material. And then if the metallization possibly is slightly different, we can do very quick adjustments to the settings and dial in a perfect tool for such a wide range of materials and metallization types. But we do have a list of that available for emailing and can send you PDF. And then in the email itself, it has a number of those tasks and capabilities detailed out.
Yeah, and I mean, keep in mind, these are by no means all of the applications we've ever done because we got to pare it down a little bit.
So we are running up on about 15 minutes left in today's presentation, so we'll answer as many questions as we can, so we'll keep our answers as direct as possible. So we still have a lot of questions to get through, which is why I mentioned that. So Kelly wants to know something, and maybe you guys can just comment on this, and we can get to Kelly if we have this, but he wants to know if we have any photo examples of microjoints for partial depaneling small PCBs where the PCBs can be handled and shipped with the panel for easy depaneling at another location. Maybe, Rolla, do you know if you have anything like this?
Kelly, I think I've actually spoke to you before, so I think you should just give me a call or send me an email. I'm not sure that I understand your question fully with the micro joints. I think you're maybe talking about tabs, but with the paneling in general, you're able to either depanel the full part, you're able to depanel only a tab, or you can depanel most of your circuit and leave a tab. So you have several options. Whatever you design in your data is what the laser is going to do. So, but yeah, please give me a call or just send me an email and we can go more deeply into that specific application.
Thanks, Marilla. I have a question from John who wants to know about the type of software package we need to control the lasers and if they work off of Gerber files from circuit design. And this is one of the great benefits of UV.
Yeah, absolutely. The software that comes with the laser systems would be LPKF Circuit Cam and Circuit Master. And it does import DXF, Gerber, GerberX, HPGL, ODB++, and excellent files to bring in that data. And our software actually calculates and translates it and then adjoins it so that it knows what type of tasks you want to do. Do you want to do surface structuring? Do you want to do drilling? Do you want to do cutting from the inside of circles? Or do you want to do outside cutting for depaneling? And so that software is included with every machine that we offer for UV depaneling, UV prototyping, UV production. And absolutely, Gerber import is straightforward and very easy with our software.
Gotcha. And it's great that you can go straight from the CAD data to the machine. Just want to reiterate that. It really makes everything very accurate. Nadir has a question. It says, what is the typical pulse energy that you can supply?
The pulse energy, there's a constant number for the pulse energy with the UV lasers. And there's specifications that we can talk about, but it's a 6-watt laser source. And those are really getting into the really in-depth pulse frequency, travel speed, and adjustment details. And I can email that to you once we get an understanding of what you're looking to achieve. And if you email me, rgrondin@lpkfusa.com, happy to send information your way on the pulse energy.
Also, keep in mind we have the stronger laser source as well. That's about double the power. So that's why we need more specific information about your question.
And you can also, there's a lot of things that are adjustable. So travel speed, pulse frequency, actually the lasers allow you to adjust power. And with that, the software has a percentage and gives you an actual power output at the material and then also knows the power output at the source. That way we can maintain machines very consistently for several years so that you can continue production applications. Even if eventually laser sources start to wear down, we can still keep customers operational.
Gotcha. Jody has another question. He says that he has a dicing operation for ceramic chips. Could a UV laser cut ceramic chips?
Okay, I'm not sure. I mean, we cut ceramics quite often. We see that, alternate way to cut ceramics is dicing. So we can cut, any type of ceramic. I mean, I think when you say ceramic chips, I would like to get, for you to elaborate. What do you mean by chips? But yeah, you can cut, ceramics pretty easily.
Gotcha. And then David wanted to know, he said that we mentioned higher power available for thick boards. He says he's interested in drilling fired ceramics 15 to 50 mils thick, but he needs good throughput. Can you elaborate on current capability and power just a little bit for his fired ceramics 15 to 50 mil thick application?
Okay, so 15 mils is actually pretty thin. We can process ceramic with a 6-watt source that's 15 mils pretty efficiently. I mean, it all depends what your current method is and what your goal cycle time is. We have the stronger UV laser that can cut it faster. So as I said, we would kind of have to talk a little bit more about your goal cycle time. But also keep in mind we also have a IR laser that we can use for cutting ceramics. The trouble with ceramics, you can get micro cracks after the fact if you use way too much power. So it really depends on your application and your goal cycle time, but we have options.
And it is common for other lasers on the market to drill ceramics very fast. And the UV lasers, because the wavelength and absorption with AL203 and ceramics, it's a slower process, but it's cleaner.
Yes.
So you can drill faster with CO2 type lasers than you can with UV, but you do have that higher energy, higher heat, higher slag. So the UV's a little slower, but a cleaner process. And perhaps the higher power laser could actually give you faster output with that. But we're doing this already with the 6-watt UV laser in the industry.
And the nice thing is, even though it may be a little bit slower than, let's say, CO2, you eliminate that post-cleaning process that also takes time. So, if you take everything into consideration, UV, in terms of processing ceramics with a laser, UV is a good option because you can drill, cut, and you can ablate. There's all sorts of capabilities there.
Is that everything? All right. No, I want to thank you guys. That was a great answer. We have a few questions left. We have 8 minutes, so we have plenty of time. I want to bring up one more question from Michael, who wants to know, why are the UV laser prices similar to carbide cutter machines?
Because of the UV source.
Yeah, the laser source, the 6-watt UV laser source, and sources have been coming down, especially with LPKF generating our own laser sources. We have more control onto the engineering that goes into it to make them more stable and source our own materials and then give that price reduction straight to our customers because we're eliminating more middlemen that are involved with all the different aspects of it. So UV lasers are coming down. Carbide cutting systems, the PCB milling, are using lower cost spindle motors instead of higher cost diode pumped laser sources. So there's a big gap between those two because it's two very different technologies.
Yes, and I mean a lot of the customers that we see interested in these type of systems are just not able to use other methods because of the other methods don't have the capabilities, and also they may have a lot of yield problems with the method they're currently using. So you really can't compare routers, let's say, and lasers in terms of capabilities.
Gotcha. Yeah, UV is definitely can do a whole lot more things in terms of versatility than just a router can. I have another question coming in from Thomas, and Thomas says, what is the item we are working on is not etched from a panel, but a standalone item? Is there a fixture to hold it?
You can cut one part or a whole panel. It really doesn't matter. If you are working if you're working with something that's not populated or maybe just populated on one end, we could probably use a laser with a vacuum table and that would hold it down. If not, we can get a fixture made for that specific part, and you can still put multiple parts on a table at the same time and increase your throughput that way as well.
Yeah, we use a lot of small scrap pieces for the research and development side, and the vacuum table always included on the prototyping machines. If there's unused areas of it because of a small section, you can actually block that and focus the energy to your smaller sections of material. So, and that would correlate to production until you get to the point where you would need the fixture and run high volumes. So, absolutely.
Gotcha. I have actually a comment from Juan Carlos Castillo Garcia, who actually won our My PCB contest. If you guys don't know, we recently had a contest where we had the users of our CNC milling prototyping systems, as well as our laser systems, send in applications they had made on their applications. And Juan Carlos got first place. He won a Raspberry Pi. And he says, very interesting. Thanks for the invitation. I'll go ahead and follow the UV system. So I just want to say, Juan Carlos, thanks again. And I want to throw out some love for winning the My PCB contest. That's the end of the questions on our list. We'll go ahead and hang out for just a minute. If you have any more questions, I don't see any via Twitter. You can always submit them via Twitter at LPKF_USA. We'll hang tight for 30 seconds, and then we'll jump out. Okay, so I got a good question coming in right now. Nice last-minute question from Juan. So before everyone else jumps out, he says, what sets LPKF laser depaneling machines apart from other manufacturers providing UV lasers? This is one of those show-me questions. So Marilla, Rory.
Yeah, so it's actually kind of exciting because the UV laser systems that are offered through LPKF really offer high control and high precision and very reliable. LPKF has a tradition in the industry of providing machines that have the highest quality components and German engineering that are going into making machines, and we follow what customers are looking to achieve. So these machines are developed basically to match what customers are asking for. And as a company, the company puts back 20% of all profits into research and development, so that we're continuously offering the latest and greatest to our customers. And to give you specifics on the UV system, really it comes down to components: the scanner, the galvo, the laser source itself that we generate to make it as stable as possible, and that leads to a more reliable and accurate machine.
And what I wanted to mention that's really important on the production side is, if you remember that slide where we showed two machines, the prototyping and the production machine, the exciting part is that we have a production machine that's very similar in size to that prototyping one. And because of that, of course, it's more affordable as well. And please keep in mind, it's capable of exactly the same applications as our large inline systems. So that's been really exciting on our end, that there's a machine on the market now that's used for production, but it's quite a bit smaller than a traditional one. And we always encourage you, if you want to compare us to other companies manufacturing UV lasers, please talk to us, send us a sample, and you can do a direct comparison.
We've had some of those, and I remember the processing speeds and edge quality we come across quite favorably. So if you ever have a sample that's specific and would help justify purchase of the machine, then we can run a one-off sample, but really focus on exactly what you guys need and let us know, and we can work with you on that.
Mm-hmm.
All right, guys, I think that's the perfect question to end on. We are right up on the noon hour, so I want to thank everyone who attended today once again, especially the 25 of you who stuck through all the questions. Thanks. If you have any more questions, I threw up the emails back there on the screen. Again, rgrondin at lpkfusa.com, at morlowski, spelled MORLOWSKI, at lpkfusa.com. Thanks again, and we'll follow up with you soon with a recording of the webinar and a copy of the slides. Thanks again, everyone.
Thank you.
Thank you, everyone. Have a great day.